Okay, so as in the last video, we have basically completed our parallel combination or capacitors in parallel. We have covered now every important topic of our this chapter number 9 capacitors. We initially discussed about capacitors, what these are. We discussed about its unit, formula, how do we find capacitor, and we discussed about its dimension as well. Then we discussed about the some more units of the capacitance, right? Farad, microfarad, picofarad, microfarad is equal to picofarad, right? We discuss each and everything. Afterwards, we discussed about the series combination or capacitors in series, and then in the last video we completed our parallel combination or capacitors in parallel. Now some less important, I cannot say okay, these are very much important, however they are important but not as much as we have covered the last topics, right? This is important but less important. We have just theory in this, we don't need to understand anything, we don't have any concept in this. The concept which we had in our topics, we have already understood those. Now this is just theory, so we are going through our book, that is synth board book, right? And this is page number basically 185, right? So we are going with the types of capacitor initially, right? Okay, so now see, we are going with the types of capacitor. Capacitors play a very important role in various electrical circuits. They play a very important role in various electric circuits, right? Very basic English, it is understandable to everyone, especially radio circuit, right? So they have given one important term as well, especially radio circuit, right? Here we classify some common types of capacitors. So we have four common types of capacitors here given below. As you can see, the first type of capacitors is what we call the variable capacitors. Variable capacitors, right? This type of capacitor is used to control, this type of capacitor is used to control basically continuously for turning transmitters and receiver signal. Important point, right? Transmitters and receiver signal. So what variable capacitors is used for? Variable capacitors are used to control the capacitance continuously for turning transmitters and receiver signal, right? Then we have film capacitors. This is the second type of capacitor, right, which is known as film capacitors. So film capacitor consisting of relatively large family of capacitors, right? They are consisted of large family of capacitor, means here we're not going to have only one capacitor or two capacitor, however we're going to have more than two or more than three capacitors, since this is the large family of capacitors, with difference being in their dielectric properties. There would be only difference in their dielectric properties, however all capacitors would be same, only there would be difference in the dielectric properties, right? So film capacitor are basically a family of large number of capacitors. There would be only difference in the dielectric properties. We will be studying about the dielectric constant in today's video. That basically would be the dielectric properties or dielectric constant of the insulating materials, right? So they are available in almost any value and voltage as high as 1500 volt. So you need to learn this as well, as high as 1500 volt. Film capacitors are used in power electronics. They are used in power electronics, phase shifters, X-ray flashes, and pulsed lasers, right? So now we have third type of capacitor, which is ceramic capacitors, right? These capacitors are used in high frequency circuits. They are basically used in what? High frequency circuits, ranging from audio to radio. This is important point, audio to radio, right? So ceramic capacitors are used in high frequency circuits and ranging from audio to radio frequency. These capacitors are also called disc capacitor. So we have the second name of ceramic capacitors, and those are known as disc capacitor. Let me write that here so that it can be more clear to you, right? It has basically two names, right? So now we have electrolytic capacitor, last but not the least, right? These capacitors are generally used when very large capacitance values are required. So whenever very large capacitance values are required, we use the electrolytic capacitors. The majority of electrolytic capacitors are polarized, means they have opposite charges, positive and negative. They are polarized. Electrolytic capacitors are generally used in DC power supply. They are generally used in DC power supply circuits due to their large capacitance. As we have already discussed, when we require the large number of capacitance, we use the electrolytic capacitor. Electrolytic capacitors are polarized, and we use them in the DC power supply circuits because they require large capacitance and small size, and they have a very small size which help them to reduce the ripple voltage, right? Which means it helps them to lose the voltage, right? So in today's video we have basically completed our four types of capacitors. The first one, variable capacitors; second, film capacitors; ceramic capacitors; and electrolytic capacitors. Now we are going to study or learn the dielectric constants of insulating material. Let me go through that. We have discussed each and everything, right? So here we have our dielectric constant, right, which we know is represented by ER, right, known as what? Relative permittivity, right? Relative permittivity. Okay, so now we have our first insulating material, which is vacuum, right? Vacuum. And the dielectric constant of vacuum is 1, right? Again, we have air. In air we have 1.0006, right? You need to learn these. We don't have any concept in this, as I earlier mentioned. In today's video we don't have any concept. We just need to read the theory, right? So that we can understand how many types of capacitors we do have, what are dielectric constant of insulating materials, right? Now we have telephone. In telephone there is dielectric value 2, right? Then mineral oil 2.2, this is polyethylene 2.3, waxed paper 2.5, epoxy 3.3, PVC 3.7, nylon 4.1, bakelite 5, mica 7, and water 81. Now as you can see, you can check or you can notice or you can observe one thing, right? We have dielectric constant very much greater when we have insulating material water, right? And we have you know what, this dielectric value very less when we have a medium or insulating material called vacuum, right? So ER is here, as I already discussed when we were discussing chapter number 8, right? We were discussing in chapter number 8 initially. In electric fields we already discussed that ER is never less than 1. It is never less than 1. It would be equal to 1, or ER is always greater than 1. However, it would never less than 1, right? So let me write this here. Never less than 1. Always greater than 1 or equal to 1. So ER is greater than or equal to 1 but never less than 1. As you can see here, right? The dielectric constant starts from 1, which means ER can be equal to 1 but is always greater than 1. It is never less than 1, right? And the greater value of ER is when we have insulating material water, right? So what we discussed in our today's video, we basically covered our four types of capacitors initially. Those were what? Wait, let me go through it. We have four types of capacitors, common capacitors. So one, variable capacitor; second, film capacitor; third, ceramic capacitor; and electrolytic capacitor. Which capacitor has two names? Ceramic capacitor. Another name of ceramic capacitors is disc capacitors, right? Which capacitors is used in DC power supply circuit? That is electrolytic capacitor. Why? What's the reason? Because they are large capacitance and they are very small size, which help them to reduce the ripple voltage, right? Then we discussed about the dielectric constant. The dielectric constant is very less when we have a insulating material vacuum, and we have a dielectric constant very much greater when we have insulating material water. ER, relative permittivity, is never less than 1. It is always greater than or equal to 1. So in today's video we discussed these two important topics, right? This was all for today.